this is something different, and this isn't a lead code round, but I just want to practice a motif or some programming pattern that you might see in a fair set of interview questions. And this is breadth first search. So for example, given a 2x2 array above, count the number of islands. So a lot of the motif for breadth first search is having a visited set, right, or a hash map depending on your language, and then you need some queue, and then while your queue is not empty, and then in your queue you would append something, namely whatever element that you have, right? And then you would just look at each of the neighbor of, so for example, we have like node, you have like first node, and then first node's neighbors are all appended to this list, and then you would pop this, and then all of first node's neighbors you'd visit, but as you're visiting them, we'd have second node's neighbors, third node's neighbors, etc. So, and then, at the end, you're not going to visit any nodes in this visited set, right? And then you're going to just run through this until you're empty. Because eventually you're going to, for any breadth first search, you visit every node, and once every node's in your visited set, there's nothing more to push in the queue, so then your queue would eventually run out. So how do we do this problem? We just say islands is 0 to initiate, and your set is just a initialized set because we haven't visited anything yet. In range, we can say rows, and then for j in range, columns, and then we can define the rows as the length of the A. Not sure why I did that. And then length of A of 0 is the columns. And then for each of these, you can say current, you can say node equals AR of ij, and then if node not in visited, then you go ahead and you do your BFS. Yeah. So node not visited, then you would probably need a queue, and then your queue would not append your node, and while queue, you would go ahead and explore neighbors, and then for each time you find a node that's not visited, because we know the rest of this loop is gonna propagate and BFS and mark all these ones as visited. The next time you find a node that's not visited, it must mean that it's a new island. And then at the end, you return your number of islands. So then what about this? This is kind of like the core of the thing. So you append this node, right? And then while your queue, you want to explore neighbors and then mark those neighbors as visited. So, right. So actually, if node is not visited, yeah, so while queue, you want to, current node is queue.pop0. So in this first case, you would have it be empty, and then we would check its neighbors and explore its neighbors. So who are its neighbors? It's gonna be, if you go left, sorry, yeah, that's, yeah, left, right, down, and then up, right? And then how do we deal with these boundary conditions elegantly? Can't really deal with it elegantly, but you can say, well, if yeah, you can say occur coordinates is just gonna be for D in directions. Your coordinates can just be I plus D of 0, comma J plus D of 1. So now these are all the neighbors that you're visiting. And then if her coordinates 0, meaning this row is greater than or equal to 0, and her coordinates of 0. So basically your which row are you on is less than the number of rows. So not less than equal to, it must be less, because rows minus 1 is your last thing. Current 0 and current coordinates similarly is less than the number of columns. Then you actually check that node, right? So if node not in visited, and then I'm missing something here, and node equals 1. And instead of action node, I need to append ij. And while Q isn't empty, this current node has this coordinate like this. And lastly, you want A of cur coordinates 0, cur coordinates 1 equals 1. So if it's 1, then we would go ahead and then add it to visited. Okay, and then so EFIJ, and then yeah, so we have our current thing, and then for D in directions, we also need to do right current node, which is ij here. We're gonna actually just refactor this because current coordinates is already in the tuple form. But basically, if this is inbound and it's a 1, then we would go ahead and add it to the coordinate. And one thing that you might do is you also want to add this to the queue. This is a little bit more organized because you can kind of think of this as an initialization of actually, hold on. Because one way I like to think about this is anytime I append something, I also want to just go ahead and add it as visited. So these two lines pair pretty well together so you don't forget. So for example, here I am appending it, but it also pairs together with this adding. So let's run through this. So the current node, I add it, so like this one, and then I'll find its neighbors. So like here, I'll also add it because then it's either 0 or it's out of bounds. And then so visit.add current node. So the neighbors are not diagonal, it's just up, down, left, right in this particular situation. So then we would add this to visited, so we would never visit this again. And then we would append this to current coordinates. So then this one would explore this one and this one. And then depending on what you append first, you'll visit maybe this one. And then these two are visited again. Right, so then these two are marked as visited, and then these will explore its neighbors, mark those as visited, and then yeah, and then this one we would, I guess it doesn't matter if we explore, but we would still explore it because it's already been pushed to the queue, so it doesn't matter if it was marked visited because its neighbors, like this one, hasn't been visited, but it will find that it's 0. Anyway, we go through this, we pop this, and then the queue empties. So then this outer loop will just kind of keep iterating over here, and then we'll just do the same thing here. And then these are all visited, these are visited, and then we'll do one more thing here, and then do one more thing for these 3 ones, and then yeah. So that's how that should work. Why is return islands red? Let me just run this. Outside function. Oh. Right. So islands is wrong. So where do I update islands? Oops. So what's happening? What the hell is happening? Oh, current node equals, I can't pop it yet, because if I pop it, then my queue is nothing. I'm not sure why this, yeah, I can actually execute. So fine, if I find the first one, I'll append it, and then while the queue is active, I'll just, current node is this guy, and then I'll add it to visited, and then for all of its neighbors, I'll also add them to visited, and then I guess this is redundant, but it doesn't harm it. Because then you're re-adding the same thing. But now it's stuck. So it's printing like 1, 0 again and again. Oh. Yeah, this is a pretty nasty case statement. Oh, and So every time I print these current coordinates, I've added it to the set. So why? Yeah, this is really frustrating. I really hate this so much. Current coordinates, yeah, so I should have added all these in sets. And then ij is 0, 5 because it's not in it. And ij is 0, 6. And then, but then ij is 1, 0. But then how can... Oh, I see. Actually, what does node do? Yeah, node is just a value check, but the coordinate is not. So this is 5 islands. 1, 2, 3, 4, 5. Would this be 4? Yeah. Would this be 5? Would this be 6, 6, 7? Okay, yeah, I guess it works. Yeah, I guess with all these kind of like weird pointers and stuff around, maybe something I could have done better is explicitly say, well, this is node value and then node coordinates. And then do like, you know, node coordinate and node val is 1. And then just be explicit as opposed to having implicit values. Because I know visited stores a bunch of coordinates and node coordinates is like this. But anyway, that's this problem. And I guess the main thing I wanted to practice was this motif of BFS, where you do a q.append of whatever your current node coordinate is. And then while the queue isn't empty, you'd go ahead and pop the node that you're looking at and then add it to your visited. And then for all of its neighbors, or called the fringe layer or whatever, then you go ahead and create a new set of coordinates in the same type of unit as the original, node. In this case, a 2x1 tuple. And then once you have your neighbors, then you do a bunch of condition checks to see if it satisfies boundary conditions. And one thing I forgot is make sure that it can't be visited. Otherwise, you run an infinite loop, and then your visited.add your neighbors, so then you don't revisit it again. And then you'd also append your current coordinates, which is going to be something that you revisit later, because then you want the neighbors of the neighbors. And so once this neighbor is pushed into your queue, then you can explore the neighbors of these neighbors. And then this is more particular to this problem, but I just increment the islands here because I know that the visited will just get updated. So each one represents one island exploration, and then so if you run to a new coordinate that's not in visited, that must mean it's a new island, so then you just return the islands.